Oh, I'm fine. Oh. I like it's like Inception. I like that.
Oh, I'm on. I'm sorry. I'm on. Thought I wasn't on there. Here we go. This is Algebra 3, and it's a little different. We're not in my house right now. We are actually here live in the classroom. Say hi, everybody. Ooh, you're on YouTube right now. All of my YouTube followers from Sweden, I know you're sleeping right now. I apologize for that, but we are doing this live. This is really good. If I mess up, we'll do a little Adele. We'll start it over, okay? And we'll go from there, all right? You saw the Grammys. All right, so let's get this underway, and we'll get it rolling. We're going to start with number 6 here. So if you got it, we'll start with number 6. We'll throw it down, okay? All right, remember that anytime we have multiplying, dividing, or simplifying, we are always going to first factor. Really, all of these problems that have the ability of factoring, we're going to factor first, okay? So we're going to do that first. Now, one cool thing about this, and it's good that I'm putting this on the podcast here, is the fact that any of the restrictions that you do will end up being, I don't want to say bonus. What do we call it now? Challenge points. That's right, okay? If you're at GAC watching this, I apologize for that. So we're doing just challenge points on the restrictions. Yeah, Lawrence, what's up, man? Correct, yes. And so what we're going to do is we're going to take the right side. We're going to flip that bad boy, okay? So when we do, we're going to have x squared plus x minus 6 all over x squared minus 10x plus 16. So if you want to first flip the right side, that might be easier to do. That way we know, that way we figure it out before we end up actually factoring. So once we get to this point, we're going to factor all 4 sides, top and bottom of both. So as I factor the top left, what would that factor to? 6 and 4? Okay, so we could try 6 and 4, right? But remember that has to add to be equal to -5, right?
8 and
3. 8 and 3, okay. We could try 8 and 3. And again, if you need to, put on the side the number and then like -24 and find the factors, and that way you could kind of figure out what equals -5. But we know that this is going to be x minus 8 and x plus 3 on the top left. Now, what about the bottom left? What 2 numbers multiply get me -12?
-4 and 3.
Good. So we have x minus 4 and x plus 3. Good. Very good. Okay. All right. So let's look at the top right here. What 2 numbers, when multiplied, get me -6, but when added equal 1?
-2 and 3.
Good. Yeah. And so we could do -2 and 3. You could say that either way. All right. There's fine. That's good. And x squared minus 10x plus 16 gets me what?
-2 and -8.
Good. Now, is there anyone that says, Coach, on one of those, I struggled with factoring them or whatnot? You need help on? Your G to G? Okay. That's for those YouTube. That's what that means. All right. So, what are my restrictions? What can x not be equal to?
+4, -3, +2, and +8.
Nicely done. Good. And that would be actually one challenge point on the test. And I put it on there, state restrictions. And I think I put 4 times that you would do that for, okay? Yeah, so any of the bottom, right? We don't want the bottom equal to 0. Because if it did, it would be undefined, right? Oh, this is off to the side. I'm sorry. What was on top, it's out of there. I put it off to the side. You're right. So it's gone. It's not there. So we're just going to now use what 2 numbers now are kind of the same thing that we could start canceling. Well, we could cancel x minus 2's, x plus 3's. We have a little cancel party. And we're left with now x minus 4. And again, that would be my answer, right? The only thing that I would say is make sure a couple people started in maybe other classes would cancel out like x minus 2 and x plus 2. It must be the exact same thing. So you might want to just make a note of that. It must be the exact same factor that's there, okay? All right, again, multiplying, dividing, simplifying, all 3 the same thing there, okay? All right? Hannah, we're good there? Are we all good around? Hannah, are we good? Okay, good. Everyone good around?
Yes.
All right, that's number 6. Does someone else want to throw out another even one?
10.
Let's do number 10. Oh, man, that's a tough one. Okay, I'll tell you this. There's one of these on the test. All right.
Oh.
Now, the actual factoring of like when A is not 1, when A is like different than 1, if it's 2 or in this case 6, those ones are a little tougher, aren't they? Okay. Bless you. Okay, so in number 10, I would say number 10 is either the first or second most difficult problem on the test. All right, so that's and this one's tough. Okay, all right. So as we approach this one, if you were to get this one, I would say this one would be a bonus for you to get. Okay, I would. This one's just a little tougher. Okay, so for instance, in this one, we want to factor first, right? Does everyone agree that the top parts of these you don't have to factor?
Yeah.
Okay, it's already set up for us to where we're simplified. The key now is trying to figure out what the factors are of both numbers 1 and number 2. Now, I'm going to do the A times C method because I know a lot of you do. Some of you will do the check and guess method, which is completely fine. But this will be good for us just to kind of get the idea of how to factor these out. So let's take these on the bottom, 2x squared plus 5x minus 3. Now, in this, I do the A times C method. And when I do A times C, I get what?
-6.
-6. Good. So we're just going to put that off to the side. Okay? Yes, Lawrence. A times C is whenever A is greater than 1, we multiply the first value, which is A, times the last value we call C, right? Remember in the quadratic, we know it's A, B, and C? So it's A times C is what we call it there, okay? Okay? And by the way, if you're like, Coach, man, this one's tough, this one is tough. There's not really a whole lot else to say. It's just a tough one, okay? As far as going through it, we can go through this again in the morning if need be. Now, whatever the first value is, we're going to put that as the factor of 2x and 2x, right? We'll put that in. Whatever we see, we put it there. Now, what two numbers when multiplied get me -6, but when added get me +5?
5 and 6 and 1.
Good. Yeah, 6 and 1.
I have one question.
Yeah, go ahead, Maddie.
Why did you put the 2x in the front?
Good question. Because with the A times C method, the way we've done it, and you'll see how it'll end up being simplified, we always put whatever the A is in for both factors. Some people and maybe tutors or other teachers have done it where you do check and guess. That's not wrong. You could still do it that way. This will produce the right answer every time. And that's why I kind of like it. But you can do like checking and guessing. That's okay. You could absolutely do that. So then we have a +6 and -. Can I take anything out of 2x minus 1? Can't. So we leave that as is, okay? What about 2x plus 6? What can we take out? A 2. And we're left with?
X plus 3.
X plus 3. So what we can do is replace this top part with x plus 3 and 2x minus 1. Now, just to make sure that we get this, because I know that was a little tougher here, let's set up the room over here on this side to actually do the second one, which would be over here, okay? So we're going to bring 6x squared plus x minus 2, and I'm sorry, not set it equal 0. We're going to factor this, okay? So what's the A times C?
-12.
-12, good. What do I start each of these factors out with there, Lawrence? 6, good. 6x, good. What two numbers when multiplied get me -12, but when added get me 1?
-3, 4.
-3 and +4, good. So then I ask myself, what can I take out of 6x minus 3?
3.
Good. And when I do, what am I left with?
X minus 3.
Okay, it's -1 is right, but 3 goes into 6 how many times?
2.
2. So we'll have 2x minus 1, right? Does that make sense? Okay. What can I take out of 6x and 4?
2.
2, good. And when I do, what's left here?
3x plus 2.
3x plus 2, and so that's how I get this side. So I have 2x, I'll put a closed one, 2x minus 1 and 3x plus 2, okay? Now, here's the thing. Regardless, you're going to need to know how to factor those out, okay? For not just this one, but for other ones as well. So whether you know what I just did A times C, you need to just make sure that you know how to factor both of those there. Hannah?
So I know how to do all that, but there was one time on MML where I did that.
Yeah.
And then it wanted me to put out on the outside what I had taken out. And I know you say that you don't do that, you just leave it alone.
What I've taken out.
Like here, point to the board.
Yeah, I think when what they're saying is like you're saying this 3 and 2 put on the outside, right?
Yeah.
I hear what you're saying. No, you're good. What they're talking about in that is if we did GCF of something, you know what I mean? Like if it was completely aside. So side note, if I had 3x plus 6, right? And I said factor that, Hannah, you would say what?
The 3 on the outside.
Good. This is side note, by the way, y'all, just so you know. So that would be true, and you would leave the 3 on the outside, right? What they're saying is with this one, when you have a 3 and a 2 within the A times C method, you're going to drop these. Now, without seeing that problem, I'm not 100% sure. I'd have to look at it and kind of explain a little bit more. With these, you're going to always, with A times C, you're going to drop them every time, okay? But we could talk later on that and check it out. Okay, Morgan?
So for the ones where it says like simplify and state, those ones you only cross out the like denominator if it's at the top two. You get what I'm saying? But for the ones where it says when it says solve, that's when you can take out if the denominators are the same, you can take out the whole thing, right?
Correct. Anytime I say solve, I'm actually solving for x. I'm trying to isolate x.
Okay.
Take out the denominators.
But for
Correct.
like the multiplication and like
Yeah,
the
the beginning
division
ones.
ones, those ones you can only take it out if it's like one on the top, one on the bottom, right?
Correct. And with adding and subtracting, whatever our common denominator is, we're just going to put that on the bottom.
Just go across.
Correct. So like what's the CD here? X plus 3, good. And 2x minus 1, because it is shared, right? You see that? So we only put 1 in. And 3x plus 2, right? Now, and I get it. I get it. It's tough. Okay, completely. But let's talk through this. What is this one missing? 3x plus 2, right? That's what that's missing. So what I do to the bottom, I do to the? Good. Okay. All right. What's this one missing? X plus 3, right? So what I do to the bottom, I do to the top. Now, is anyone confused right now? Okay. Maddie, do you get how I got the blue right here and this yellow?
Yes, I did.
Do you get how the common denominator is this over here?
I just thought the common denominator on the left side was 2x plus 3 and then 2x minus 1. Where did that 2 go?
Trying to say that one more time. I'm sorry.
When we did the common denominator over, when we factored on that side, the left side.
Yes.
Over there, did we get 2x plus 3 and then 2x
Great
minus
question.
1?
The 2 drops because of the part of the process there. The 2 is just dropped.
Okay,
Whatever
we just
number
took
that's
that 2
there.
out?
Same thing with this one over these 2 over here. When you took those out.
Okay.
Does that make sense? So we drop those in that case. So now we've got these as 2 common denominators there. And again, that's where I've got this left over. So the 3x plus 2 and x plus 3 are the only 2 that are missing. One on one side, one on the other. Okay? All right? So again, now once I get to this spot, okay, I'll do this because you can go back and watch this on the podcast on this side. I'm going to erase this on the bottom to get my little more room. But you can kind of rewind that if you need to. Once I get to here, right, what is this all going to be over top of? Good. That's exactly right. Good. Okay. So what's 4x minus 1 times 3x plus 2? Well, I can multiply 4x times 3x to get what? 12x squared. We're just distributing that or foiling. 4x times 2 is? 8x. Negative 1 times 3x is? Good. Negative 1 times 2 is? Negative 2. Very good. Now let's do the other side. X times x is?
X squared.
Good. X times 3 is? Good. This 3 times x is? And 3 times 3 is? 9. Very good. Okay. Now, but there was a negative in the middle, so what happens there?
Does that get distributed to all of this?
All of these ones will change sign, so it'll be negative. What would this one be? Negative, negative, and negative. Okay. All right. All of those there. So 12x squared minus x squared gets me? 11x squared. Good. What's this? Oh, it's actually 8x minus 3x is 5x minus 3x is, and then minus 3x again would be, yeah, negative x. Once I put it really, all of these x's kind of go together here on that side. So that's how I get to negative x. Does that make sense on that? So it's just combining like terms. That's all we're doing on that. Hannah, go ahead.
Was the first thing you said 11x squared? Just making sure.
Yes, that's correct. Yes, ma'am. And then negative 2 minus 9 gets me negative 9, right? And then after that, we're left with x plus 3, 2x minus 1, and 3x plus 2. Okay, I'm going to tell you right now what I'm going to do. Here's what I'm going to do. After doing that problem, here's what I'm going to make an executive decision. The restrictions will not be a bonus anymore. This problem will be, okay? So if you do the restrictions, that will be required on there, okay? So stating the restrictions, and it's only for certain ones, and I'll tell you on that. I'm going to make that the required part, and I'm going to make this specific problem. There'll be one very similar to this. That will be the bonus. It will count against you. Does that sound okay?
Yes.
Okay. I think that'll give us more confidence going in. So don't spend all night doing this one. All right. That's not the main thing. If you get it, great. If you want to, watch it again, that's great. But we're going to do that and go from there. Hannah?
I think the top should be -11.
Did I miss?
2 and -9.
Oh, and that would be what?
-11.
-11. Just making sure you're paying attention. That's good. Awesome.
Wait, how did you get minus x?
Good question. 8x minus 3x is what? 5x, right? 5x minus 3x, and then minus 3x again. That's how I get that negative x on that
And you
side.
don't want the zeros for this problem?
No, I will not say state restrictions on this one. Okay? Yeah. I don't know. We'll see.
It better.
What's the restriction?
X is not equal to -3. When I added 1 divided by 2, x is not equal to 1/2, and x is not equal to -2/3. Okay. Hey, that took quite a bit, and again, I'm going to hit these problems in other classes. So if you're like, man, that was only 2, well, we're to keep plugging away on those even ones. So if you got another one, throw it out there. If you got another one, 14.
All the restrictions are negative, right?
Actually, no.
Not necessarily, because look at the 2x minus 1 right here, right? On that one.
I like
11x minus x.
Do this. Could I do another?
Oh, minus. I wrote it down wrong. Sorry.
Gotcha. We'll do that one.
Did
you
you
may-
write down the restrictions for that problem?
Yes, so we could say x is not equal to, by the way, I wouldn't do this. A challenge point there. X is not equal to -3. 1/2, right under thirds.
Wait.
Okay. So that would just be the restrictions. That would be extras there. Okay. All right. Morgan, and then I'll go.
Can we do 14 next? Because on here it says mistake on problem.
We'll do that. Yeah, well, that's one. I've got that highlighted right here. We'll do that one here. Okay. All right. If you need some more help on that one, we will come back. We can come back to that later on. We'll do that. Okay. Let's take this one. This will take not as long here. 1 over x minus 1 minus 1 over x plus 1 equals 2 over x squared minus 1. This is more of a realistic problem on the test. Remember, first we have to always factor. Is there anything we can factor here?
X squared minus 1.
Yep. What would this turn into? X plus 1 and x minus 1. So, question, what is the CD or common denominator here?
X plus 1, x minus 1.
Good, because that's what is included within each of these three. Does anyone have questions on that? Okay. So what is this one missing?
X plus 1.
What I do to the bottom, I do to the
Top.
good. So we'll put an x plus 1 both top and bottom. It has a 1 up here, so if I multiply by 1, what would I get? Just x plus 1, right? Is everyone good on that? Okay. What's this one missing? X minus 1. What I do to the bottom, I do to the top. Good. Okay, again, times 1, so we'll keep that there. This negative we'll bring into play here in a second. Okay, so just hold off for a second. Is this missing anything? No. Now, remember, if we are solving, do we have a common denominator?
Yes.
So what can we do if we're solving here?
Oh, you can cross it all out.
Correct. Cross them all out, okay? If we only when we solve. If you want to, take a highlighter, okay? All right, I think there's a couple of people in this room that use different colors for, different things on there. In that moment, man, use a highlighter and highlight the ones that say solve if you need to. So we're going to cancel these out.
Solve if you
because what I do to one side, I could do to the other side, right? So here's what we got left. We have x plus 1 minus x minus 1 equals 2. Now, here's what happens. This negative in the middle does what?
Distributes to that.
It's got to go to both, right? Some people will just do to the x, but remember, it's got to go to both values. So what would this turn to?
Negative x plus 1.
Negative x and plus 1 equals 2. So what's x minus x? 0x, right? And 1 and 1 obviously make 2.
So 2 equals 2.
Okay, 2 equals 2. So question. Yeah, Ashley.
I don't understand the 0x.
Well, just take.
That's weird, isn't it? If I have 0 of anything, right? It's gone, right? It's done. It's not there, right? Now, it might not have been this exact problem. I think we did another one in class on this. But the question is whether it is, once we have no x's, right? Because usually we're solving for x. The question now is, okay, there are no x's, like as far as like 0, it's 0x. So is 2 equal 2? Is that true? Is 2 equal 2? Yeah, it is. So if it is true, we say all reals. Or you could just say all values. It's fine. You could say all values there. Okay? And if it was false, let's say we had 1 equals 2. Is that true?
No.
If it said this, it doesn't. But if it did, you could say false, and you could just say no solution. Okay? Now, here's the thing. One thing you need to know is this. If you showed great work and at the end you just give me 2 equals 2, I'm giving you most of that answer. Okay? I'm giving you most of it. All right? Because you showed me, you gave me great work. You did a great job on that. Probably like minus 1 point or something. All right? So, again, the details are important. I'm not saying they're not, but they're not the main thing. The main thing is showing me the work, and then at the end, telling me what the answer would be from that. Nicole, and then I'll get to Lawrence.
Can we do 16? Yeah, I was just going to ask that.
Yes, and then Lawrence, did you have a question on this one? Yes, not every one. What was cool on the test, there are 4 of them that I say state the restrictions for. It actually says it and has a spot for it.
Okay.
So it'll tell you when to do it. So like for this one, what 2 values could x not be equal to?
Positive 1 and negative 1.
Great. Good job, Maddie. Good work. Because again, even though we cross it out, x could not be equal to whatever is on the denominator. So it would be set them equal to 0 and be 1 and negative 1. Okay? Good. That's good. All right. 16? Are we good? Let's go to 16. Okay? Okay, so this one is very similar to the one I just did. Now, this is more of a realistic one where we have to factor the A times C method, right? Now, here's the thing. Look at 16, 17, 18, 19, and 20, okay? All right, now let's do this really quick so I get this on the podcast, all right? So if you've got the review, just really quick. Let's talk about the strategies that we would use to solve for x here, okay? Because there's different strategies that we could use, all right? Number 16, what would be a good strategy we could try first?
A times C.
A times C method or factoring, right? Which is the same thing, right? Same thing. So we could factor this to be able to solve, right? Okay, try number 17. What can we do on 17? Foil it, right? Get everything to one side. And then we could try to factor or use the quadratic formula, right? Okay? And I'll give that to you on the test. I'll give you the quadratic on the test. That's fine.
Yeah.
That's a great question. I think it'll be obvious. Does that make sense? I think so. Like that's what we're doing right here. Does that make sense? So check out 18. On 18, if I did the A times C method, right? What number would I get with A times C? 3. Are there any 2 numbers that multiply that equal 3, but when added equal -7?
No.
There's no possibility. So immediately I use quadratic formula. Okay.
So if you can't factor, you do quadratic.
Correct. Now here's the good news. You ready? You could there would be no way to factor that one on that side. Number 18 we're talking about. Number 18.
3 minus 1.
Well, it has to equal -7x in the middle on 18, right? Does that make sense? Okay. So it has to equal -17. So I don't know if I'd be able to do it on that one though, Will. Good thought though. Okay. 19. Look at 19. What could I do on 19?
Perfect.
Yeah, so we could factor, set them equal to 0. We could add 9, take the square root of it, right? Any of those options are good, okay? So here's what's cool about it. Even though 16, we can factor and do all that stuff. If you messed up and said, you know what, I'm going to do the quadratic formula, you should get the same answer.
Oh, really?
Yeah, you'll get the same answer.
Do we have to put the restrictions for that too?
There are no restrictions because there's nothing in the bottom of a fraction. So you don't have to state restrictions. You just tell me x is equal to this and this, okay? And we'll do that one here in a second.
Any of the factoring ones like that you can solve using the quadratic formula?
Correct. Correct. Except for number 20. Look at number 20. On number 20, that one we can add 24 to the other side. Take the square root of it. That's a little bit different, right?
Easier.
But the other ones you can. Absolutely. Okay? Show work. That's going to be huge for tomorrow. All right, so let's keep going. On this one, what's A times C here?
10.
Good. All right, so if it's 10, we're going to have two factors here. What do we start each of this with?
2x.
2x. Good, and 2x. All right, again, this A times C we hold on to. Remember, A, B, and C, right? So A times C is 10. Two numbers when multiplied equal 10, but when added equal negative 11. What two would that be?
10 and 1.
10 and 1, right? And what would go with those two?
Both would be negative.
Both would be negative. Good, Ashley. Okay. Now, can I take anything out of 2x minus 1?
No.
No, I can't. Okay. What about 2x minus 10?
You can take out 2.
Good. And what am I left with?
X minus 5.
Good. And then 2x minus 1, right? Because we had nothing we took out. Now, since this is equal to 0, we're solving for x. Are you good, Ben?
I'm just confused why you got 2 and 1.
Yeah, so the A times C is 10, right? What are two numbers when multiplied equal 10, but when added equal?
You get 10. I thought it was, for some reason I thought it was 5.
Correct. Normally it is. But because it has an A greater than 1, we do A times C to find the new number. Does that make sense?
Okay.
That's how we get 10. Okay? All right. So now we're going to set both of these equal to what? 0. Okay? All right. We good on this?
We're so good on
Are we not good on this?
No,
Okay.
this.
Okay. So we set them each equal to 0, right? So what's x equal to on this?
What? Positive 5?
Positive 5, because we add 5 to both sides, right? What about this? How do I solve for x on this? Add 1. Good. And I heard, was that you, Nicole, over there? Nicely done.
Thank you.
And divide by
2.
2. And so x is equal to 1/2 and 5. Okay? All right. Again, you use quadratic, you'll do get the same thing.
And we're
Same
using
thing.
quadratic for 18.
Quadratic would be for 18.
So
Okay?
for 16, we write both of those with, do we have to say like 2 solutions or something?
No, you don't have to. You just put them there. By the way, the discriminant stuff, don't worry about. Okay?
Perfect.
Number, actually cross this out.
Texting each other.
24 and 25, cross it out.
Oh, that's.
Which one's crossed out?
I don't even know what the discriminant is. Just to cross it out. I'm joking. I'm messing. Cross it out. 24, 25, cross out.
Could we also have one of the quadratic ones just a little bit?
So that's my favorite.
Yeah, let's do that one. Let's do 18. You may. Good. All right. 18. Good, good. Okay, let's hit this one. Okay, so this one, we are unable to factor, okay? If you're like, Coach, why is that? If we did the same method, A times C, we would get the value of what? 3, right? Okay, so two numbers multiplied that equal 3, but added equal -7, there just isn't any. Okay. So then, we're just going to put this into our quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2a. All right? So once we do this, the b is what? -7. But if I plug that in with a minus, it'll turn into a positive. Very good. Okay, so this will be positive because we, again, bring in -7 for that b. Okay, so just take the sign in front as the big thing. So plus or minus the square root. Okay. What's b squared? 49, right? Now, don't put in -7 squared into your calculator. Do not put -49 in. If you do, I will haunt you, okay? Like, you will not graduate. Like, I'm serious about that. Care if you're a junior or not. So, -4, what's A again?
Great.
And C is?
1.
Okay, we're going to hold on to that. and then all over 2 times 3, which would be 6 there. Good. So now let's simplify. So we're going to say 7 plus or minus the square root. What's 4 times 3?
12.
Good. And with the negative, there's only one negative here, so we'll have negative 12. So this is 49 minus 12 on the inside, okay, which turns into 37. Good. So we're going to just keep that here. And then that's all over 2 times 3, which be 6. Now, the square root of 37, are there any numbers multiplied equal 37?
No.
There's not, right? So what we would do is just say this. The 6, I like to write it like this. You could keep it like this here, or you can write it like this. 7 over 6 plus or minus square root of 37
Over 6.
over 6. You could write it like this, okay? You could leave it like this. That's fine. Just don't do this because some people will. They'll say, let's say both of these two are divided by 2. They'll just simplify these two. You can't, if we're going to simplify, it's got to be all 3 of these. Okay? Ashley?
So say if you did have like a multiple of 37, then what would you do?
So let's say it was like square root of 8 on the inside. I would say 2 numbers multiplied equals square root of 8 would be 2 and 4, right? 4 would be 2 and 2, right? So I have a pair of 2's brought to the outside. So
you just like,
just 2 root 2 or whatever that may be there.
would that still be over 6?
Still be over 6. Yeah, still be over 6. Good. That's a good one, y'all. Good choice. Any other ones you see on the even side? Maybe get 2 more in.
Can you do just some graphing one, I guess?
Absolutely, yeah. What, like a graphing?
32.
32 is a good one. Yeah, let's do that.
You ever know how to like move the jacket to the lighter? That was horrible.
I'll tell you what I will do. I'm thinking about that. I will either allow you to write it in interval notation or to graph it. Does that make sense?
There was one, it was like P.9. We did on the X.
Oh, like graph the line? No, you won't have to. I don't know why that was on there. I'll go back and look at it, maybe give you credit on that. I'll look at it. I'll look at it there. Nikki?
Like, can you just go over the language like with the brackets and parentheses?
Are you talking 32? Is that what number? 28? Yes. Tell you, yeah, let me do this. Let me do 28 because it's quick, and then I'll go 32. Is that cool? Both of those are kind of linked together. So on this one, yesterday, we kind of, I was talking to someone yesterday about this specifically, how there's 3 things that kind of correlate together, okay? So in this part, this is called interval notation, all right? So just a heads up, interval notation. In this, they want us to graph the number line. So actually, it will give us the instructions on what they want us to do. So in this, if I were to graph this number line here, what's the furthest left this graph's going to go? In negative infinity, right? So it's going to come from this way, all right? Now, what's the furthest right this graph's going to go? 0. So when I graph it, I don't need to know like each little tick mark. All I need to know is that it's going to come from 0 and it's going towards the left, right? Now, the question is whether this is going to be an open or closed circle at 0.
Closed, right?
It's going to be closed because, and here's how we remember, a bracket means closed, which also means like greater than or equal to or less than or equal to. All 3 of those are the same. So that means parenthesis is circle, which is greater than or less than. Does that make sense? That's a good thing to maybe write at the beginning. So again, these 3 go together and those 3 go together, okay? So again, then that's how I would draw that line there. Nikki, does that help you? So, which leads us into the next one. 2, well, that's a great line, okay? Woo, all right. Sorry about that. I just gave half effort on that. I'm sorry, okay? 6x plus 5 is greater than negative 2 times x minus 3 and then minus 25, okay? So in this one, let's simplify this. Again, we can almost treat this as an equal sign here, right? At the beginning, at least. So let's distribute the negative 2 to get what?
Negative 2x.
Minus 25, right?
Yes.
Okay.
32.
And here's what I like to do with these ones. Let's get the x on the left side, Okay, let's get the x over there. So, but first, 6 minus 25 gets me what? Negative 19. Good. Yeah, so negative 2x minus 19. So let's add this 2x to both sides, okay? So we got that there. So we've got 8x plus 5 equals negative 19. Now what could I do to get x by itself again? Yep, take it to the other side. So we've got now 8x and negative 24, right? And now, and this is, let's bring down this sign now, the greater than sign. So we can divide by what? 8, yep, to isolate that x. So really what we've got, and I know this is all over, I apologize, I'll put it up here. X is greater than negative 3. Now, do I flip the sign?
No.
When do I flip the sign?
Divide by a negative.
Divide by a negative, good. So anytime I divide by a negative, I must switch the sign, okay? I wouldn't be surprised if there's one of them on there. So just remember, just kind of make a note of that, you know, get to it, go from there.
What do you mean divide by negative? 'Cause
So-
they're-
Yeah, let's say this was negative 8x. If I divide by a
if the
negative,
X is negative.
the value that's with x is negative. Good question. Got it? So it then says, write it in interval notation. So you've got this, right? What is this? Can someone read this to me? X is right here. X is what?
X is greater than negative 3.
X is greater than negative 3, okay? So if you think about it, all right? If x is greater than negative 3, that means what's the furthest left of this graph?
Negative 3.
Negative 3, good, okay? And what's the furthest right it's going to go?
Infinity.
Infinity, because it's greater than, right? Now, because this is greater than, not greater than or equal to, what will be with negative 3?
Bracket. Parentheses.
Parentheses, right? Because it's not equal, right? Not equal, right? Now, if it had a line underneath it, it would be there, right? Okay. And what about infinity? Infinity always has the same thing. Always. Yeah. In negative infinity, always has the same thing. And that's how I put it interval
Do you
notation.
care if we do bracket, parentheses, open or close?
Yeah, can we do
Because
on the
rounding still does it one time, we like do it.
Oh, I don't care when you graph it. You do you. I'm good with that. Okay.
so on the
Isn't that
number
y'all saying now?
what she was asking is on the number line when we graph it, we can either do instead of the open or close circle, we can do a bracket or parentheses on that line.
That's perfect. I've had different people do different ways. You could put a bracket here. That's okay.
Okay.
As long as you know it's kind of the same, I'm good with that. And on this, I don't think it said graph, so that would be it. That'd be it there. Okay. There's only one other one that I really wanted to hit on, and I wanted to hit on this one because it's one that's reviewed, but we got it wrong on the test. 2x plus 5 squared. I bet you half of you missed this one. All right.
Which one is
On the last test, number 35, just the first one. Okay. I know it's odd, but it is odd. That's true. Okay.
Wait, is this number 35?
it? Yeah.
Yeah. If I did this, what would I have to do?
Write it twice.
Write it twice, okay? Squared means that there's twins, okay? All right, there's 2 of them. Now, I swear if I had $1 for every time, I swear my daughter would not have to pay for college. That'd be a scholarship because it was literally, I saw a lot of people multiply these 2 and these 2. But remember, we are what?
Foiling.
Foiling, right? 2x times 2x gets me 4x squared. 2x times 5 is? 5 times 2x is? 5 times 5 is good. And then we add them together to get this here, okay? All right. Coach Jay signing out. Hope you have a fantastic day. And are you serious?
Did it go off?
Did that not even?
It says live on the bottom, so I don't know.
Oh, Lord, please. Please, hopefully this went through.
It says
Uh,
stop broadcast, probably.
Have a good day. We'll see it. Well, hopefully this